So it's similar to binomial.
Yeah.
It either lands on uh, red or it doesn't. Let's see. So the spinner is spun until it lands on red, or spun 4 times in total. So S is the number of times it lands on red.
Yeah.
So what's the different number of times that it can land on red?
Nick landed it twice.
So let's see. So it can land on it on the first try,
Yeah.
and then the game would be over. Wait, let me see. It lands on red or until it's been spun 4 times. Okay, so if it lands on red once, the first time, what's the probability of that?
1/5. Or 2/5.
2/5, yeah. Okay. If it lands on red, let's see. No, S is the number of times it's spun. So if it's spun twice, what happened there? If it was spun twice,
Then would it be out of 4 then?
so for it to have been spun twice, it must have been
Landed on blue.
blue first, yeah,
And then red.
and then red. Okay, so what's the probability of blue, then red?
3/5. Then it goes down to 2/4.
No,
Squad.
doesn't change. So it's 3/5, and then times.
2/5.
Yeah, it doesn't. We don't remove anything. And so probability that it's spun twice.
6 out of 25.
Yeah. Okay. Any other possibilities?
Blue, blue, red.
Yeah. So if it's 3 times, it must have been blue, blue, red. So what is that one?
3/5 times 2/5 times 2/5 again.
Well, once it lands on red, then the game is over. So if it went
Oh.
blue, red, it would be over. That'd be 2.
So it'd be 3/5 times 3/5
Yeah.
times 2/5.
Yeah. Well done.
Which is 18 out of 125.
Yep. And then the last one.
There are two. You have blue, 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 and then blue, 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 red.
Let's see. Yeah, so or 4 times in total. So 4 is the last one.
Yeah.
So that one is blue, 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 red. Okay.
Yeah.
What is that one?
3/5 times 2/5 times 3/5 times 2/5.
Yeah. And so what will that be?
Okay.
And you can always do 3/5. What's a short way of writing it? Times itself 3 times?
3/5 cubed.
Yeah. Yeah. Times 2/5. 3, 6, 9, 7. I think it's 54.
Cubed times 4. Okay. (54/625).
So 54 over 625.
Yeah.
However, there is another possibility. The other possibility would be blue 4 times, because it says 4 is the maximum regardless.
Yeah.
So what's probability of blue 4 times?
3/5 cubed. Not cubed. To the power of 4.
Yep.
Which is 81/625.
Okay. And so what goes in the last box? What do we do? Any idea what number?
Do we add the two together?
Correct. Yeah, because it can either be blue, 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 red, or blue, 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 blue.
Yeah.
Add the two together.
You get 135 over 625.
5 over 625. And so that's kind of what this is all about. There's an easier way. This last one is the hardest one to do because you've got two different things.
Yeah.
And so for the last one, what you can do is 1 minus the others because they have to add up to 1.
Okay.
So try that. See if you get the same number.
So we add all the others together.
You can add all the others and then subtract it from 1. So,
Okay.
yeah. I want to try as well.
I got 27 over 125.
Let's say 2 over 5. That should be 125. 1 second. Why did I do that? 125. I'll get 0, will I? Hang on. 135. I need to get rid of that. That's what it's supposed to give us. Oh, what am I doing? 18 over 125. I can't copy. Hang on.
How come you I added them together, you need to subtract them?
Well, you then subtract that from 1.
Oh,
So-
okay.
So do your
Okay.
answer, subtract from 1. 2, 6, 18. So 27. And that is, what is 27 times 5? Hang on, how do I copy that?
Is that 130?
27 times 5 is 135. Yep. And so that's just a quick way that you can do the last one.
Yeah.
Hang on. That's great. Oops. There we go. Okay. So I'll let you try this one.
Okay.
Unless you have any questions about that previous.
So for this, would you do 3 over 7 times 4 over 7?
So, well, I'd have to do number of... Wait. Until it lands on green, or it has spun 5 times in total. Let me just see how they wrote this previous one. X and probability S equals S. That was 1, 2, 3, 4. So they called it X. Okay. I'll call it X. And the probability that green equals this particular one. So what are the possibilities here?
There's 5 possibilities.
What are they?
3 over 7 times 4 over 7.
No. Possibilities are the number of...
Oh, as in like, oh, right. There could be green and purple.
So it's the number of times it lands on something. Number of times it lands on green.
5 times.
Alright. Any other possibilities? So it lands... you spin this thing around. If it lands on green, the game is over. If it lands on purple, the game continues.
Yeah.
So we want... So what's the number of times it can be spun?
5 times.
Okay. There are many other possibilities. So for this one, it can be spun once if it lands on red the first time. It can be spun twice if it lands on red second time.
Yeah.
3 times if it lands on the third time, and 4 times and then 4 times is just the maximum.
Yeah.
So this one?
So you could spin it once, you could just get purple.
I believe the game ends if it lands on green.
Oh,
Yeah, so
so you
once.
spin it once, you could lose. You spin it once, you might land on purple, and then spin it again, you might get green.
Okay, so how many spins would it be then?
2.
Yeah, so it can spin once, twice.
And then it could go purple, purple, green, so it's 3 times.
Yeah.
And then purple, 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 green, which is 4 times.
Uh-huh.
And then purple, 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 or added to purple, 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 green.
Yeah, and we can use one
That's right.
minus for that one.
Yeah.
Okay, so what's the probabilities?
So there's the first one, 4/7.
4/7, yep.
The second one's 4/7 times 3/7.
Mm-hmm.
Which is 12/49.
12/49.
The third one is 3/7 times 3/7 times 4/7.
Yeah.
Okay.
And you can write it the short way if it's easier.
Yeah. I got 36/343.
Yep.
And then you do 3/7 cubed times 4/7. Which is 108/2401.
Mm-hmm.
And then you add them all together and minus from 1.
Yep.
Which is 81/2401.
401. Let's take a look. 4/7, 12/49, 36/303, 108, and 81. Great. Any questions about that?
No.
That's good. Let's see this one. A biased coin is tossed 4 times. Alright, so how would you start this one?
Would you write out a table?
Uh-huh.
And then it's tossed 4 times, so it could either be tails, and that's only 1 flip, so you'd lose.
Mm-hmm.
And then the next one would be heads then tails, which is 2 flips.
Right.
And the next one could be heads, heads, tails, which is 3 flips. And then the last one is heads, 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 tails, or heads, 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 heads.
Mm-hmm.
Or you can just minus it from 1.
Mm-hmm. And how many would that be?
What do you mean, how many would that? Oh, 4 times.
Yeah.
4 flips.
Okay. And what is probability of tails?
1/3.
Yeah, I think you'd be fine for the rest of this.
Yeah.
It's just this one here would be, I don't know, probability x equals x. I don't know.
Yeah.
That it lands on that thing. No. It's not x equals x. It does need to be a different number because it's not the same number. Probability, no, h equals h or something. Okay, good. Probability s equals x. Wait. It was the same. I'll have to look into what that's about. Okay. Oh yeah. For this one, what is the probability of getting what is the probability? Yeah, what is the probability that x is greater than 3?
Greater than 3, as in like in the table 1, 2, 3, 4, 5.
Yep.
It's 2 over 5.
No, doesn't work that way. What's the probability? Well, what possibilities are greater than 3?
Did you add the two
Yep.
together, 4 and 5?
Yep.
And you'd get 189 out of 2,401.
89 out of 2401. Yeah, great. So you can then, once you've made the table, you can use it. Like here, they wanted the probabilities greater than 2.
Yeah.
And we've got more of these things. I think we have the idea.
Yeah.
Okay, let's try this using binomial expansion.
So for this, what you need to do is it something choose something and then something squared times something squared.
It's the idea. Do you remember?
So is it 8 choose 1?
This we want the term for y to the 5, and so we only need the 5
Okay.
one.
And then is it 8 plus 0.8 plus 0.2?
So it's 0.8 is the first one,
Yeah.
and 0.2 would be the next one. And powers?
Is the middle one the highest, so it'd be 8?
The middle one, well, the middle one, I'll just put in the y and the r. So we want the term y to the 5. So what would the power have to be for middle one?
5.
Yeah, and actually I think this choose thing is in the wrong place. That's a 5. So what's the other one?
Is it 3?
Yeah. And so this was a choose 3.
Okay.
So what is that?
Okay. So do I need to put in anything for the x and the r?
We'll just have to do those manually, so I just leave those out.
I got 0.15.
Yeah, rounds to that. Okay. Wait a second. Is that how this thing works? Yeah. All right. And so what is the y? What is the r? What would be the full thing?
Pardon?
What would be the full thing for this?
Oh, would you like all the other like chooses?
Uh-huh.
It'd be 8 choose.
No. You'd have to then put in y to the 5, r to the 3.
Okay.
But yeah, okay. That's all right. Let me fix that question. It's difficult. Okay, how about this one?
I don't know what it means by NMP.
The number of trials. So how many times is it spun?
8 times.
So x is binomially distributed. Number of trials is 8, and p is probability.
Is P 5.
Can't be more than 1. The number of times the spinner lands on yellow. And so, probability of yellow?
4/5.
So that's 4/5. I'll write 0.8, will I? I'll write 0.8. Or I'll leave it as 4/5 and we'll just do this. So that's the how you could model how this thing works. Okay, find the probability x equals 5.
So is that 5 times everything in the bracket?
That would be, well, the probability lands in it 5 times. That would be, I believe, red 4 times and yellow once. So what's the probability of red 4 times and yellow once?
Red 4 times is 1/5.
Yeah.
To the power of 4.
Yeah.
And then times 4/5.
Yeah. However, 4/5 of the 1. So that's there's a problem. There's a problem. X equals 5. Hang on. It lands. No. It's spun 8 times. And it lands. X is the number of times it lands on yellow. So yellow is 4/5. So that's going to be 5.
Okay.
And so what would be the other power then? So this one, the game doesn't end if it lands.
Is it 20?
No. This one, the game doesn't end if it lands on something. So they have to add up to 8 spins in total.
So would it be... Oh, so it'd be 3.
So that would be 3. Yes. However, there are many different combinations. Sorry, this isn't right. So it could be like red, 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 and then yellow, 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 yellow. However, there's like many possibilities, like red, yellow, yellow. It has to land on yellow 5 times.
Yeah.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And it's spun 8 times. Any idea how you get all the possible combinations of red and yellow?
No.
For this one, it is 8 choose, and this is yellow. 8 choose 5.
Yeah.
Yeah, and so it lands on red 3 times, yellow 5 times, and because there's like many different combinations of red and yellow, it's times 8 choose 5 would get you all that number.
Yeah.
And that should look familiar. What is that number?
Okay. Okay. I got 0.15.
Yeah, it should be that same one, is it?
Yeah.
Yes, and so the combination of y to the 5 was that. Okay. Yep. And okay, part 2.
So it'll be 8 choose 5, 1/5 to the power of 5. 4 over 5 to the power of 3.
I believe it would be 8 choose 3.
Okay.
So what was it? 1 over 5 to the...
To the 5.
Yeah, I'll put 4 over 5 first. So yellow 3 times, and so red 5 times.
I got 9.18 times 10 to the power of minus 3.
9.18 times 10 to the minus 3.
Yeah.
Let's see this. Yeah, 90092, like 3 zeros and then... Yep.
Yeah.
Okay, part 3. How could we get 7 or more?
Okay. Or could you do 8 choose 7?
7 or more. Yeah, 8. Let me think. Yeah, 8 choose 7.
So it'd be 8 choose 7. And then was it just 1/5?
Yeah.
And then 4 over 5 to the power of 7.
4 over 5 to the 7. Yeah.
And you get 0.34.
Alright. We want greater than or equal to 7.
So do we do 8 choose 8 now?
Yep.
And you get 0.034.
0.034. Okay. So how do we get
Wait,
probability?
do you have to make it to the power of a 0?
Yeah. That should be 1/5 to the 0. And 4/5.
To the power of 8.
Yep. Because it lands on it 8 times. Lands on the other 0 times.
And you get 0.17.
Okay. And so how do we get so that's probability 7 times. That's
Add them
probability
together.
Yep.
And you get 0.51.
And you're rounding this a lot. We'll see how this... So 0.5033. So you'd have to keep it to like 5 sig fig until the end. But I've looked it up, and unfortunately this is... you have to show you're working out for this one. But there is a quicker way. But you have to do it. Great. Put that there. Okay. Okay, how do we do this?
So for this, you need to do binomial expansion.
So it's binomially distributed. So it's type of binomial expansion. Yeah. Like what we were,
But we don't know how many times
hang
the
on.
variable is like
So
spun.
this one we had to binomial expand it to get the y to the 5 term.
Yeah.
And so we did 0.8 y to the 5. And then the other two were h choose 3 and 0.2 r to the 3. So they would add up to the 8 possibilities. And so this one is using a similar idea. X is binomially distributed, 8 number of trials, and probability of 4 over 5. And so this one, number of trials is 12, probability is a sixth, probability that X is 2.
The 12 choose 2.
I think it's 12 choose 10. It might be the same number though. I think it is the same number. But I'm just going to do 12 choose 10, so it's exactly the same as binomial expansion.
And then is it 1/6?
And then 1/6.
To the power of 2.
Yeah.
And then would it just be 2?
And then it would be 5/6 probability of failure.
5/6 to the power of 10.
Well done. Yeah, so whoops. So try that one.
Okay.
I just want to see 12 choose 2 and 12 choose 10. I think they're the same thing. So 12 choose 2 is 66. 12 choose 10 is also 66. Yeah.
Yeah. I got 0.3 to two decimal places.
Let's do it to 5 decimal places.
Okay. 0.29609.
Okay. How would you do B?
Would B be 12 choose 3?
12 choose 3. Yeah.
And then it would be a 6 to the power of 9.
Yeah.
And then 5/6 to the power of 3.
Yeah, that's fine. And then how would you do C?
Is that above or equal to 1?
That's less than or equal to 1. How do you people not know that?
So for this, would you do 12 choose 1?
Yep.
12 choose 1, and then 1/6 to the power of 11, and then 5/6 to the power of 1.
5/6 to the 1. Okay.
Which gives you 2.7564.
Times 10 to the minus something?
Yeah, times 10 to the minus 8.
To the minus 8?
Yeah.
Alright. What was it?
2.75636.
64 times 10 to the minus 8. Okay.
And then would you do 12 choose 0?
Yeah.
So you do 12 choose 0, 1/6 to the power of 12, 5/6 to the power of 0, which gives you 4.5939 times 10 to the minus 10.
And how would you get x is less than or equal to 1?
Do you add them together?
Yeah.
which gives you, wait, which gives you, I got -13.
Times 10 to the minus 13?
No, I just got -13.24. I put in answer plus 2.7.
I think. Did you do times 10 times minus 8? It should be to the power of.
I put in times 10 to the x in the bottom right. It's a calculator.
10 to the x. Oh, x 10x thing, is it?
Yeah.
Something went wrong. Just do it manually from now on, because it'll go wrong. Hold on. 12, choose 1. Yeah, that felt weird. No, these numbers are the other way around. So if x is 1, then a sixth is to the power of 1. Yeah.
Okay.
I was wondering about that. So, yeah, for the first one, if it lands on x twice, yeah. If it lands on x twice, then it's a sixth to the power of 2. If it lands on x 9 times, then it's a sixth to the power of 9. If it lands on x once, then it's a sixth to the power of 1. So it's the other way around for those two.
Yeah.
I'll just do this. So it's a sixth to the power of 1, that one to the 11, and then that to the 0. Yeah, so it's just the other way around, and you add them. Okay, let's see. That's it. Okay, let's try this. You might not know how it works.
No, I don't.
A suitable model would be x is binomially distributed.
Yeah.
The number of trials is like number of members, so it'd be 20. And the probability of left-handed 0.15. You have to justify our choice. There are certain things we have to say. There are two possibilities. Two possible outcomes. So instead of like head and tails, red and yellow, it's now left-handed and right-handed.
Okay.
So that's when you use binomial. That's when something is binomially distributed. Bicycle, two possibilities.
Yeah.
Two possible outcomes. There is a fixed number of trials.
Yeah.
And a fixed probability.
Yeah.
And that's when you use binomial distribution. Okay, B.
So for B, would you do 20, choose, and then something?
Yep. What would it be?
20, choose 7.
Yay, ba-ba-da-bum. Let's go with 7, yep.
And then it'd be 0.15 to the power of 13.
No. 7 are left-handed. Left-handed is 0.15. So it'll be 0.15 to the 7. because left-handed is 0.15 and there's 7 left-handed.
Okay. And then you do 0.75.
0.85?
Oh yeah, 85 to the 7.
How many trials? How many people in total?
Oh, it'd be 13.
Yeah.
Okay. I got 0.081.
So 0.081. Why'd you always do so few figures? That's only 2.
It's 0.081340.
Okay. And how would you do part 2?
Wait, the last number of that, put it to 1.
Okay.
So would you do 12, 20 choose 2?
It says less than 2.
20 choose 1.
Yeah.
Should be 20 choose 1, 0.85 to the power of 19, and then 0.15 to the power of 1, which is 0.13670.
Okay. What else?
And then you do 20 choose 0.
Mm-hmm.
And then you add them together.
And so what's the rest of the stuff?
Like the answer.
No, the working out for that one.
First, for the bottom one.
Yeah.
20 choose 0, and then 0.15 to the power of 0, and then 0.85 to the power of 20.
That's it. And what would you do with those two?
Add them together.
Okay. Yeah. So did you put into your calculator for this first one? What did you put in? 20. I don't know what you're putting in your calculator. 20. So this previous question, 20 choose 7, 0.15 to the 7, 0.18 to the 13.
Let me check. So is the 22 7, 0.15 to the power of 7, 0.85 to the power of 13?
0.15 to the 7.
Yeah, I put that. And then I click. I got 0.0.
No. So did you? Yeah, now you have 0.016.
Yeah.
Yeah. So do you know where you went wrong with that?
I think I probably just put it in wrong.
Okay. So yeah, 20 choose 7, 0.15 to the 7, and then 0.85 to the 13.
Yeah.
Okay, then that one, you add those two.
Yeah.
Alright, part A up the top. And let me just check, hang on. We justify our answer. The random variable can take 2 values, left or right-handed. a fixed number of trials and a fixed probability of success. We assume each member in the sample is independent. All right. And so maybe I'll just add that in. Trials are independent. That's what I'll write. Trials are independent. To me, that's what fixed probability implies. But just in case, I need to check the mark scheme for that. Okay, how about this?
So would this be a binomial distribution?
Yeah.
Then it'd be 10 and then comma 0.08.
Justify your choice.
What, because like there's like a total of 10 switches?
No. What do you mean by that?
Like,
so fixed number of trials?
yeah.
Right. Why else would you use binomial distribution?
Because you have one probability of like every switch, like one switch, like switch being faulty, like a chance.
So fixed probability. So
Yeah.
it's not like tree diagrams where you take something out, chocolate out of a box, eat it, and then take another. That's like the tree diagrams, it's conditional probability is changing, whereas this has fixed probability. Okay, what else? Bicycle.
As in like they're two different things.
Yep, two possibilities, so two possible outcomes. And then the third one, trials are independent.
Yeah.
Okay, what is part B?
So for this, would you do 10 choose 4?
Yep.
10 choose 4 and then 0.08 to the power of 4.
That's 10 choose 4. 0.08 to the 4.
And then it would be 0.92
Yeah.
to the power of 6.
Mm-hmm. So put that in. See
And that gives you 5.2156 times 10 to the minus 3.
Might just 5.22 to 3 sig fig with 3 zeros. Yeah, 10 to the minus 3. Okay, great. What is the working out for B down the bottom?
So would you do 52.6?
Yeah.
And then it'd be 4%.
And how do you do 4%?
What is it? 4%? 50.
Do you know what 4% is as a decimal?
0.04.
Yep.
And then it would be to the power of 44. Oh no, it would be to the power of 6.
Yeah.
And then it would be 0.96 to the power of 44.
That's it. Great. That's good. What is the model for the top one?
So it'd be binomial distribution. And it'd be 20 and then 0.12.
Yeah. Justify your choice.
because it's a fixed probability
Fixed probability.
and there's a fixed like sample.
Fixed number of trials.
Yeah,
Okay. What else?
and they're independent.
Trials are independent. One more.
And the fixed probability is independent.
No. Bicycle. How many wheels on a bicycle?
2. So there's 2.
Two what?
Variables, like fixed variables.
Two possible outcomes.
Yeah.
Yeah. Either it's working or it's not. Either it's left-handed, right-handed. How would you go about doing B part 2?
So for that, what you do? 52 is 47.
More than 47.
So 48.
Yeah, 48. What else?
And then 49 and 50.
Yeah. I'm not gonna make you do that. So this is a good one. Let's try this one. Find the probability. So let's just do B from B. Or we can, yeah. Lands on a prime number. So how many prime numbers are there?
What? On the dice?
Yeah.
Is it 2, 3?
I think it's one more.
5?
Yeah, 2, 3, and 5. Out of 1, 2, 3, 4, 5, and 6.
So it'd be 3 out of 6.
Yeah, so that's a half.
Mm.
So we want probability that he rolls 4 prime numbers. So this one, he rolls it 10 times. So X is binomially distributed, 10 and a half. Find the probability he rolls 4 prime numbers. What would that be?
So this would you do 10 choose 4.
10 choose 4.
And then a half to the power of 4.
Yeah.
And then a half to the power of 6.
I believe so. So get that number.
Okay. Not 0.2051.
Okay. Let's say one more.
I rounded that, so it'd be 0.20508.
Okay. 0, 8.
There's no 1 there.
Yeah. And part C.
So would you multiply it by 2 the answer?
No. It's a new thing. I will say Y is binomially distributed. This time it is 7 number of trials. And any idea what the probability is? We want the probability he rolls 4 prime numbers.
Is it 4 over 7?
It is our answer to the previous one.
Oh, okay.
So that is the probability of rolling 4 primes, and so yeah, we want now using this one, the probability that he rolls
So is it
4
okay?
primes
So
twice.
it's 7 choose 4.
Twice. So we
7
now
choose 4 to the power of 2.
7 choose 2.
7 choose 2, and then you do 0.20508 to the power of 2.
Yeah.
And then you do
1 minus it.
1 minus it
To the power of
5.
5. Let's take a look. Oh, so I don't have the working output. 0, 2, 0, 1. Let's put that in the calculator. See what it says.
Okay. Not 0.2803.
0.205. To the 5. Is that what you got?
Yeah, I got that.
Yes, great. So now we have to actually use our previous answer for that. So
Yeah.
part B was the probability it rolls, like you get 4 primes, and then C was the probability of 4 primes twice in 7 experiments. So 7 choose 2 with that probability. Let's see this one. I just want one more if I can of this thing. Find the probability to at least 50% of arrows. Find one that actually hits the bullseye. So let's do A and C, I believe.
So it'd be 20, 0.6.
Yeah.
And then for the other part, for A, it would be. So would you?
No. This needs to go with cumulative. My mistake.
Is that the next chapter?
Unless, yeah. So I need to get, if I can, an extra question, but it comes up a lot. Hang on, see if extra question for binomial probability distribution of this type. If not, remove, because there's this thing where you get the probability and then you sub it in. Comes up a lot in cumulative distribution. But I only have one question for that. All right, binomial distribution. What do you give yourself?
Probably between a tick and a half.
Yeah, we're doing great. And then cumulatives after that. Yeah. How was that for you, Adam?
Oh, it was good.
Any questions for me in general?
No.
All right. Well done. You did great. And
Thank you.
have a nice weekend. And I'll talk to you next time.
You too.
Cheers.
Bye.
Bye.